But there's also a converse to it, and this diagram is actually the converse of what is written here. So this says, if you have an inscribed triangle, and you know that one of your side lengths is a diameter, then you can conclude that it's a right triangle. So this is actually a diagram of the converse of this. Okay? So, but you need to know this theorem and the converse. It's going to go both ways. I may give you a diagram where you know it's a right triangle, then you would have to conclude that the hypotenuse is a diameter, or vice versa. All right. Sweet. Now let's go back to page 357. Because I think that's going to answer some of y'all's questions. For instance, number 16. If an inscribed angle in a circle intercepts a semicircle, if that is the intercepted arc, it is a semicircle, then what is true about the measure of the angle? Right, the measure is equal to 90 degrees, the angle is a right angle. Okay. There's also another one in here is number 18. How can you use what you learned in this lesson to prove that the sum of the measures of a quadrilateral inscribed in a circle is 360 degrees using inscribed angles? The whole thing of what we just did of like where we look at the opposite angles and they both intersect the entire circle. So that description that we just got done talking about. So other than that, were there questions on this one? On this page? Yes? Number 19. Draw an angle inscribed in a circle such that its intercepted arc is a semicircle, and label the measure of the inscribed angle. This is the whole diameter thing. So you have a semicircle is half a circle. Those are created by diameters, and so if I drew an angle that intercepted that arc, it would have to be a 90-degree angle. Because an inscribed angle is 1/2 the measure of the intercepted arc. So the intercepted arc is 180 degrees. Therefore, the inscribed angle that intercepts that is half of 180 degrees, which is 90, right angle. One more, if there are, yes?
23.
Number 23 says, name the quadrilateral that when inscribed in a circle has an angle pairs in which one angle measures twice the measure of the other. Now it's very vague about which angles it's talking about. It just says angle pairs. So is that opposite angle? Is that consecutive angles? It's very vague. But let's take a look at this. So we have a circle. We've got an inscribed quadrilateral. And apparently, there's one angle x. And an angle pairs where one angle is twice the measure of the other one. So if this is one of my angles, then apparently there's an angle that is twice. Now I'm not sure if they're talking about opposite angles or if they're talking about consecutive angles. But if this is the case, we need to figure out, well, what are these angle measurements? And so, well, opposite angles of inscribed quadrilateral are always going to be 180 degrees. So, if this were the case, if the opposite angles had this relationship where one of them is twice as big as the other, then I can solve this equation, and we'd get x is 60. That means that would be 120. This would also be 120, making this 60 degrees. And again, I set it equal to 180 because that theorem tells us that opposite angles of inscribed quadrilaterals are supplementary. So again, this was kind of vague. Angle pairs, is that opposite angles or what? So I just went with opposite angles because that is the theorem that we know about inscribed quadrilaterals, that the opposite angles are supplementary. They add up to be 180 degrees. So that's why I chose this equation. It solved that. And so if these are the angle measurements of that quadrilateral, then what is the most specific name for that quadrilateral? I disagree with trapezoid. Isosceles trapezoid. This is a situation that it would be an isosceles trapezoid. Okay, and on to the last page of homework. 362. On this, lesson 25-3, so this is the third page of homework. This is all about angles whose vertex is inside the circle somewhere. Inside the circle. So if that's the case, what is the relationship between the angle whose vertex is in the circle somewhere and the intercepted arcs? Okay, one more time. What is the relationship between an angle whose vertex is in the circle and the intercepted arcs? 1/2 the sum. 1/2 the sum. So, it's not going to get any easier than this for number 11. This angle measurement, which yes is congruent to that because vertical angles are always congruent. This angle is basically the average of this intercepted arc and that intercepted arc. So to find the average, you add two things up and then divide by 2. Well, multiplying by 1/2 is the exact same as dividing by 2. So it will not get any easier than that. X is 90 degrees. That is right in between 70 and 110. But that's what the rule in your notes say, that the angle is 1/2 the sum of the arcs. So questions on this page? 14. Number 14. Number 14, they are asking for an expression in terms of x and w that is equal to the measure of measure of the arc AC. So you're not going to get a numerical value in the end and say, oh, the measure of arc AC is 60 degrees. It's not looking for a numerical value. It's looking for an expression that involves these two variables, x and w. So x is currently representing the measure of angle BMD. That's what x is currently representing. Well, what do we know about the measure of angle BMD? And we have to use this variable w, so that's arc BD, and we're solving for the measure of arc AC. So how is this angle related to arc BD and arc AC? 1/2 the sum. So I'm going to write that. This angle measurement is 1/2 the sum of the measure of arc AC plus the measure of arc BD. This is just taking our theorem and making it apply to this diagram. The angle is 1/2 the sum. And that's what you should have written on your notes last class. Angle is 1/2 the sum if the vertex is inside the circle but not the center. So now we're just going to replace these arc measurements and angle measurements with the variables that are given. X is representing the measure of this angle. So apparently, x is 1/2 the measure of arc AC. That's okay that we don't have something to replace it with because that's what we're searching for. Nick, you got it right here? So from here, we need to solve for the measurement of arc AC, because like I said, we're not going to get some value. We're not going to get some value like this many numerical degrees. It's going to be some expression that involves x and w. There's a lot of ways you could go about this. You can distribute the 1/2 and then continue to solve for the measure of arc AC. What do I mean by solve for the measure of arc AC? Get it by itself. Okay? Solve for. Okay? Right now, x is solved for. X is that nonsense. We need to get it so that the measure of arc AC is equal to whatever. I'll do it both ways. If you distribute it, then you're going to get x is equal to 1/2 the measure of arc AC plus 1/2 of w. I need to get this by itself, so I'm going to subtract 1/2 w from both sides, so I get x minus 1/2 w is equal to 1/2 the measure of arc AC. Now, there's a couple ways you can look at this. Right now we're multiplying the measure of arc AC by 1/2. So the inverse operation would be division. So divide by that same exact value. But back in grade school, if you had 3/7 divided by 1/2, dividing fractions, what was the rule that your teacher taught you? Not dividing fractions. Flip both of them.
Oh, no, that's reciprocal.
Fried chicken. What? Okay. Keep, change, and flip. So when you multiply fractions, it's the same. Sorry, dividing fraction. It's the same as multiplying by the reciprocal. The whole reason I wanted to show you this is because dividing by 1/2 is the exact same thing as multiplying by 2. So if you want, you can divide by 1/2 on both sides, but in the end, that's really just taking both sides of the equation and multiplying by 2. So when you do this step, however you want to look at it, divide by 1/2 or multiply by 2, you're going to get 2x minus w is equal to the measure of arc AC. That is your expression. The other way, so we're here. If you wanted to, you could just get this expression by itself, the measure of arc AC plus W. What's currently happening to that entire expression is that's being multiplied by 1/2. So you can divide everything, the whole right-hand side and the whole left-hand side, by 1/2. But divided by 1/2 is the same thing as multiplying by 2, so you'll get that that's 2x, and then subtract w. In the end, in terms of x and w, the measure of arc AC is 2x minus w. That's just using your theorems and then manipulating equations, solving for different variables. And you guys did that in Algebra 1. Like they would give you something like x is equal to 2xy divided by z, and they would say solve for a, and you would have to manipulate the equation and get a completely by itself. So that's what they're asking you to do. Okay, we need to move on. Okay, so that's all of our homework. You can put that away. I want you to get out a brand new piece of paper. If you need some paper, there's some right underneath the projector on the cart in the middle of the room.